Welcome to Data Skeptic Time Series.
This is Data Skeptic Time Series, the podcast about how to predict the future based on historical sequential data. Episode number. We find most of the guests for Data Skeptic by crawling the archive and looking at recent research publications. It's actually a really cool thing we built. I want to show you listeners eventually, but it's kind of rough around the edges right now. Anyway, you can guess the type of content it's been sending me lately when I search for time series things. And I'm always delighted when something a little off the beaten path, or at least to my point of view, comes up, such as the paper predicting next season designs on High Fashion Runway, which serendipitously is from previous guest Yusan Lin. I reached out and we caught up about this work and some other things she's doing. I have always found it kind of perplexing the ways that ML might be applied to these things that have such a human element. So it was really good to catch up and get her perspective.
Hi, my name is Yusan Lin, and I'm currently a research scientist at Visa Research based in Palo Alto, and I'm part of the artificial intelligence team.
Can you share a little bit about what that entails? What do you work on, if you can share anything along those lines?
So my work mainly consists of two portions. One is the direction on recommendation system. More specifically, I have an interest in any kind of fashion-related recommendation or fashion prediction. And the second portion is using unsupervised techniques to do different type of anomaly detection tasks.
I'm surprised a little bit to hear that Visa's involved in fashion and that sort of thing. Certainly we use Visa to buy our fashion, but where does the recommendation system come into play?
I think I get that a lot as well. Every time I talk to people about, I do fashion recommendation at Visa, people are like, what? Visa does that? So that actually is because we have a very rich set of behavioral data from the consumer that we inferred from their transaction history. So we can get really good understanding of what they like in terms of restaurants, in terms of their travel preferences. And beyond that, we also can get a feel of what they like in terms of apparel. And these are things still pretty long-term planning, because as you can imagine, there's a lot of gaps we need to fill in terms of what exactly the consumers have purchased. Those are actually the information we don't have right away. But assuming we have those, and assuming we know that the retailers and merchants they have purchased before, we can actually gain really good insights of consumers like and to infer their fashion styles.
Well, in any commerce setting, there are lots of time series things we can look at and forecast, inventory and sales and that kind of thing. What are some of the fashion-specific things that are worth forecasting and interesting to you?
Sure. So I think fashion actually has an underlying extremely unique characteristic in terms of the timeline. Compared to a lot of different trends that you look at, fashion has extremely regular changes across time, more specifically when we look at runways. So we know that every year there's this specific time that either New York or Paris will hold fashion runways. And those are happening at the exact same time every year. So we call them fashion season. And those actually are the main drivers of pushing forward for the trends that are changing and then from one designer to influence another in the next season and so on. And that even further triggers down to what the mass market later on will catch up on and then get inspiration from the high-end designers. So I would say that that is an extremely fruitful and rich information we can leverage to do forecasting.
So I definitely can see where those runways are major events. They're kind of the pinnacle, I guess, where fashion trickles down from. So certainly there's a lot of information there, but I'm not clear, what is the data set?
I think at first glance, everything was seen very unstructured. So I started thinking about this problem probably all the way back in 2012. So that actually led to my first conversation with you probably 5 or 6 years ago when I was leveraging a data set I came across on Vogue.com. Or I think a prior generation of that website would have called style.com. So they have a collection of probably already 2 decades of runway reviews, as well as those really clearly taken runway photos of the models. And they organized in a way that they put it out every season, and then every designer, they will have collections of pictures and really professional fashion expertise writing about what has been presented on the runway this season, to the detail that what are the designs, what are the materials, and what are the silhouettes and then what is the color that are being included and the patterns. So those are the really rich data sets that I was using for all these work that are related to fashion runway analysis.
When you're going to do a forecast, I mean, there's the joy of mathematics, of course. There's good reason to forecast, but I assume there's more to it. Who's going to take that forecast and leverage it for some insight?
So I think the people that can benefit from those are actually several roles, I would say. So first and foremost, from designers' point of view, for designers that are also in the industry, since it is highly possible these kind of trend information are usually pretty secretive among each other because they are all competitors. When they actually get things revealed, that's when they actually see the show, right? They will be able to see what the other designers are putting out there. However, if we are able to forecast ahead of time, then for the designers, it's easier for them to catch the trend early on and not having to wait until everyone already put their designs out at the show. So then the designers can be more on trend. And then I was thinking more of online of smaller designers will be able to gain more information at an earlier stage. And that's on the designer front. But if we're talking about like merchants or retailers, that will also be extremely helpful because if they can forecast ahead of time, thinking ahead of time of what will become trendy or what will be the so-called in season at the time, they can actually stock in the products ahead of time, right? They can plan it accordingly and then thinking, okay, this is what's going to be very popular in the coming few months, in the coming season. They can plan their stock inventory accordingly. And then finally, for consumers, of course, if some consumers want to be more of the trend leader, that can be also one of the tools that they can leverage to stay on trend.
So the image data, you've got set a couple decades, that's a rich data set, but it's also still feels a bit unstructured. What do you do with the images?
What I did was at first taking the images and then I wanted to get features of them, right? And there are many, many ways that we can actually extract features given an image. So more traditional ways would have been you can extract out what are the more dominant colors in there, what are the brightness and other image related type of features. However, I was inspired by other works I was working on at the time, more specifically the outfit recommendation works. And I found that extracting the image features from pre-trained convolutional neural networks is very, very powerful for many different kind of downstream tasks. So what I did, instead of extracting more interpretable, let's say like easier to understand features, I passed them through pre-trained DanceNet that I took that was pre-trained on, I believe, ImageNet. And then use those to take out the feature, and then every image actually became really huge vector that is 19K or so values inside, and use that as the inputs. So that is for the image part. As for the text part, for this particular paper, I didn't include that, but previously I will also pass in the text into an RNN type of language models to generate a complete review embedding, and that can also be jointly concatenated with the image embedding to serve as a one season, one designers type of information.
Gotcha. So that's now a rich quantitative data set. We can study it. Once you've turned every image into that 19K vector, what comes next?
So actually, that's the part that I think is pretty innovative in our design. So we wanted to think of it this way. So you want to capture, let's say, a trend of a season as well as the style of a designer. So I want to look at it from two dimensions in a way. So for example, you can think of a designer having their own style as the center or their core philosophy. So it doesn't matter what year or season they are releasing their designs, it's going to stick to that style, but it will evolve, right? So in order to capture that, we have a first dimension that is using an LSTM network that embeds a sequence of the designer's designs throughout the seasons. So we put out, for example, Chanel at the very beginning of 1995, what is their design? And then we put that into LSTM, and then the next step in the sequence will be the next season, and so on, up until the time that we want it to be stop the training. So that can capture one complete direction for one designer using LSTM. And another portion is we are also interested in capturing a full picture of one season, what is everyone doing? So in order to do that, for example, we can take at a one timestamp and everyone that has released their designs in that season, we would directly take a pulling of all of their features, and that can be a representation of that particular season's overall designs from everyone, right? Like an average idea of that trend. So combining these two together, we can even push it further. So we can say for one designer that is evolving throughout the time, they not only get influenced by their own design up until last season, but also what has happened for the whole market, the whole industry in the last season. So every time, say, we predict for T equal to 2, then the input will be the designer's own trend or own style at T equal to 1, and then the overall season's representations at T equal to 1. So in that way, we construct a almost like two-dimensional prediction task.
Well, I like the setup, and I can see how then the LSTM is capable of learning the sequential growth of the designers you were describing and their influences. Are you then trying to, is it a classification task or a generative step next? How do you look into the future with the model?
It's actually we design it as a simple classification task. More specifically, we have a task where we try to say generate random samples. The positive samples will be the ground truth of what happened in the next season for a particular designer. And then we can generate a random negative samples directly taking it from any other designer that are also in that particular season we want to take a guess. And the model is aimed to optimize the fact that the score they predict to be the positive sample has to be larger than the score that they predict to be the negative sample. So that is our more of like an evaluation task, I would say, for the prediction portion.
And I know you come at this from both the technical side and as a domain expert. Maybe you could help me understand how challenging is this to say, this task you've put it to, that a certain design came from a particular designer. Is that something that, everyone has their own signature and it's just figuring that out? Or are there a lot of complexities and ambiguities?
I actually would say I was surprised by how well the model is able to learn, even though when we look at the overall prediction, in my paper, I have a small table summarizing, say, the average area on the curve. And it wasn't too fantastic in a way that we are resulting in saying using LSTM, the AUC was about 78.42%. But considering the fact that this problem setting itself was supposed to be challenging, right? People will say, oh, it's impossible or it's very hard to predict what's going to happen the next season. But then we can outperform the random guess, which is 50%, by about 28%. So I was surprised by how well the model is able to capture it. So I think technically it is not difficult, but the difficult part actually doesn't come from the quantifiable portion, but more in the qualitative portion. So this paper, we stop it there. We say, okay, we can predict it well, and then we are able to show you this is the performance and so on. But how do we make it interpretable? Because once we forecast it, say we can generate embeddings and so on, but what will make it actually useful is turning those not human readable feature vectors and make them some actionable items. So say we already have the features, we can say the models can nicely forecast what's going to happen feature-wise, but what does it mean? What does it look like as an image? Or what does it mean as a text? What kind of designs can it be digested by either designer, retailers, or consumers?
Well, one danger if we're going to apply deep learning techniques is that there could be some sort of overfitting going on. Do you have any insight into what the model's actually picking up on, or ways to be sure that it's not recognizing something silly like a certain designer always wants a particular wood grain on their runway or something like that?
We didn't really notice that for this particular work, actually. But I think overfitting was a bottleneck that I faced earlier when doing more outfit recommendation or compatibility related work. But for this one particularly, I assume there might be some situations that happen this way, but I didn't notice it.
Is that perhaps, the levels you're hitting? As you said, they're better than random. Maybe they're not perfect, but I don't think perfect is the bar. Do you have any sense of where the ceiling is? If this was somebody's or a team of analysts' full-time job, would they be outperforming the model by a lot?
Oh, that's a very good question, because it will be really boring if a fashion industry is just perfectly predictable, right? So I would say a lot of times, like you mentioned, the upper limit of the model, it is capturing overall what the market is trying to do and then assuming the designer is evolving in a way following their past pattern. But we have seen again and again a lot of times the designers would decide a sudden dramatic change in their styles all of a sudden in the next season unannounced. Or our model does not take into account, which is something that maybe is something we can try, is the external factors other than things that are happening in the runway show. What are the news articles that might actually hint some change of events, like significant events happening in the industry or even outside of industry that will affect any kind of change in design or affect the release, such as the fact that if they had a change of the chief designer, chief to creative director, we wouldn't have known by just watching the runway shows all the way up until the last season. So I think these are all just a lot of factors that will take into play. So like you said, it makes a lot of sense that a model is not able to perfectly predict what's going to happen the next season.
The following message comes from Data IQ, the platform for everyday AI. Let's face it, the potential for positive change with AI is huge. But seeing that value is hard. AI-driven growth is about organizational transformation, not just technology. And today's businesses struggle with the complexities of bringing AI innovation to fruition. That is where Data IQ comes in, infusing a culture of working with data and AI every day and at every level of the company. Whether solving for the mundane, like automating forecasting, or what is the optimal number of widgets to buy, or understanding moonshots that push the limits of today's technology to grow your organization and innovate. That's Everyday AI. Join more than 45,000 people worldwide across banking, insurance, pharmaceuticals, manufacturing, retail, and more who are driving results with Data IQ. Visit dataiq.com to learn more. That's dataiku.com. VPLS is a managed service provider and managed security provider with a 20-year history of industry-leading customer service. VPLS's network and security operations centers can be an additional resource for your IT team or function as an outsourced IT department. They offer help desk, managed security, managed backup, and other managed IT services. They handle the IT needs of both large and growing companies and can help your team with IT needs of all sizes. They operate 24/7, 365. Who else does that? Maybe they're a good fit for after-hours support for your team. When it comes to things like cloud migration or backup and disaster recovery, you're going to need outside expert help. VPLS is a great fit for companies with existing IT staff and teams, but may have some gaps in their IT framework, which could include cybersecurity, network optimization, and more. They're great for companies without existing IT support who are looking for experts to manage their entire IT infrastructure. And they're great for companies looking for IT expertise for a specific project or issue. Visit vpls.com/goit to see all their offers, including a low monthly co-location rate for new customers. That's vpls.com/goit. When you look at some of the incorrect classifications it makes, is there anything insightful? Do you see why it's made the mistake or have a clue, or does it just seem random?
Yeah, that's a very good question. I cannot recall exactly the designer names on the top of my head right now, but I was remembering when I take a look at why the model was doing wrong prediction. And this actually can be an interesting side product of this model. That is, it's because those two designers are so similar. So the models was not really differentiating between them. Their designs are just so similar to each other. So it makes a lot of sense for them to get messed up. So this might be something that can be helped to group the designers together, or potential copying each other, or heavily influenced by each other, or just coincidentally they're releasing similar stuff in the same season.
Well, I was hoping we could also talk about some of your other work. I read the Fashion Recommendations and Compatibility Predictions with Relational Networks paper as well. Similar but distinct. Fashion prediction, I think we've kind of covered. Where do your recommendations take place? How does a user get a recommendation?
Sure. So that was one of my first time actually getting exposed to the idea of leveraging image features because prior to that, I was mainly dealing with social network analysis, graph-based structures, or like textual related data. So when I first looked into this problem, we were first trying to figure out what are the challenging points when we are trying to do fashion recommendation. More specifically, we don't want to just recommend apparel item one at a time to consumers because that's very straightforward and that will make fashion recommendation just similar and then can be characterized as yet another recommendation problem. And we want to go beyond that. And when we look at the challenging part and the unique characteristic of fashion, it actually comes with several folds. The first is fashion is one of the domains, one of the few domains that really takes into account of how things are combined together before you recommend to someone. Right? Or if one person is going to buy something, they will actually in the back of their mind thinking about, is this going to go well with what I have at home? So the compatibility portion comes into a big play for any kind of fashion recommendation related problem. So that is what led to us creating this work on fashion recommendation and compatibility prediction using relational network.
Could you give us the high level on what a relational network is?
So the relational network at the very beginning, it was proposed in a way that given a complete scene of images, more specifically meaning that inside of that image, you have multiple objects, and we detect what each of these objects are, and then using a relational network, you want to say whether these objects are placed in a way that makes sense. And every pair of objects, whether one is more related to another than the other pair. So if you break it down into architecture, what we are thinking is what the model is supposed to do is after detecting the objects, it will generate all possible pairs of objects inside of the observation, which is the scene image we were talking about before. And then this depends on how you want to generate each object's embedding. That's where the creativity can come from. And then you concatenate the embeddings of each object one to another. And using that becomes, say, you start with dimension k for each object. After you have a pair, then that becomes 2k, right? And then you can pass it through a fully connected network, make a smaller embedding. And after that, you want to predict, okay, given this particular pair, are they compatible with another or not? And you repeat the same steps for all of the other pairs that you have observed in the scene. And then till the end of the network, you then take an average of all of the pairs compatibility scores, and that can output as the final prediction of how compatible things are within the complete scene of objects that you have observed.
Very interesting. And can you talk a little bit about the training data for this project?
So for the fashion recommendation projects, for the data sets that we use, there are many options because for other works, they might have university collected different data sets from image corpus, or there will also be data sets released or collected, scraped, or crawled from different kind of apparel e-commerce websites. And for us, we actually went to a website. At the time, it was very popular back in, I believe, 2018, called Polivore. And then we collected the outfit data from there. It's more like a social network for users to post what they would think as a ideal outfit onto the website. So they don't necessarily have to own those things, but it's like a Pinterest board for fashion focus. So we leveraged that site and collected their data. So the data source can be cleaned in a way that each record is a complete outfit with items coming from different kind of categories, and we can have the user relationship to it saying this is the user that created it, or this is the user who liked this outfit. And within each outfit we have this outfit contains multiple items and their items images, as well as what's the description of the outfit. So that's how the data set looks like when we want to train the whole network.
Did you have to crawl that, or is that something they've like open sourced in some way?
Initially, we didn't want to go through the whole crawling process because there was actually a couple of versions that different authors of research papers have released. But we ended up crawling it because we want to curate our own set that is a lot larger than we were seeing at the time. However, a fun story that happened in the middle of the whole project is, I remember it was 2018, February or so, I started collecting the data. And then halfway through me working on it in April, the whole website disappeared. And I couldn't believe it at the time. And then it just happened happened that I think they got bought by another company, so that the whole website just gone. So we were holding on to the very precious data set that was like the last generation of that website.
Wow. You're now the official archivist.
I know.
Well, that's a nice data set to have. It's neat on a couple of accounts. One being, it's user generated and they've kind of pulled their own creativity into it. When you train a model on something like that, what do the results turn out like? Do you feel like you see an intuition behind what it's doing when you look at your own recommendations?
So I think the fact that we are using this data set actually, like you said, it's user or community curated, it's good, but it's bad at the same time because we have no way of guaranteeing the quality of the outfit. So we are just assuming the things that we crawl from the users that we believe will generate high quality data leads to high quality outfits. But that doesn't necessarily mean every time the outfit's being put together is a highly compatible and highly stylish outfit. So when we first tried it out, for this particular paper we are looking at, we were forming everything into a binary classification problem. So whatever we were given, we would just view that as a positive set. So we will want the model to answer, yes, that's a good outfit. Whereas we will create negative samples by randomly picking different items. Of course, guaranteeing the categories makes sense, but just randomly pulling different samples and then saying this is a negative set, so the model should answer no. We actually had a lot of trouble tuning and training the model. So that was part of the difficulties that we kind of shy away from this particular paper, but we knew that was a hard problem because negative sample on its own could be a huge issue. However, after training the model in a way to make it really robust and stable, we still overcame that. And then we were able to generate the model in a way, train it in a way that given a outfit, we can successfully give it a good scoring because we use a softmax, so it can be the probability of how good the outfit is. We can still provide a good compatibility score. And another thing is if we'd also designed a separate task. Given the complete outfit, we can intentionally or purposely carve out one of the items and then give the model like a multiple choice, saying among 4 items, guess which one is more compatible. And we want the model to guess the right one. And that is also a task that we found our model performs really well.
What sort of metrics do you look at for evaluation?
For the compatibility score, because it's a binary classification, so we use the standard area on the curve to do the evaluation.
Well, you've touched a little bit on some data challenges. You've always found a way at the projects we've discussed, but I'm curious if you think there's a need for some sort of, collective of a fashion data set to have the equivalent of like an ImageNet, but for fashion. Is that something that researchers like yourself would benefit from?
Absolutely. So I think it was a few years ago, something similar was released and it was called the Fashion MNIST. So we have the very standard and long-standing data set of MNIST that is the handwriting for digits. And then there's another one released that is on items. So for inside of a tiny square, there will be a shirt or a shoe or a skirt, and the training task would be leveraging that to answer what category of it would be. But I think we're definitely lacking something beyond that. So we have shown that through even pre-trained ImageNet, it is very easy for the model to classify a given image into what type of item this is. Is this a jacket? Is this a pair of boots? And so on. But we need more than that. I think we need a more fine-grained label data set to describe what kind of styles are encapsulated within a given item and what are the things that are often paired together. And also even something that beyond just me going back to dig into the runway, something that can capture also the trend portion of the images, because that is something that we haven't really as a fashion research community look into. Besides just looking at things from like at a decade granularity, people of course can easily identify these are the styles back in the 50s, back in the 60s and so on. We need more fine-grained than that, considering how things are moving faster and faster right now. Trends are changing faster than ever. I think we need something that also have the temporal information encapsulated in the data set.
When you look across change like that, obviously like fashion is kind of always changing. There's probably a momentum for it. What are some of the other factors? Like it wouldn't be surprising to hear that, political movements play in some way. I'm not quite sure how, but what influences fashion?
when I look at what happened back in the day, so let's say for the 1920s, the flapper style was such trend at the time and such an icon style at the time, or then 60s we had these hippie styles and so on. I would say back then probably it is a lot more due to the overall environment, economy, and the political change at the time. But nowadays, things are moving in a way that I'm a strong believer that is heavily due to the amount of information everyone is being exposed to right now. So the fact that we are just getting exposed to so much new styles, new trends on Instagram or Facebook, TikTok even, that is what is really driving the change in fashion.
And can you speak a little bit about how you envision the most sophisticated models in the future that you might build, take all of that data into one system and make interesting observations from it?
I think definitely considering the chatter of the social trends into the model would be unavoidable. So let's say detecting what has been more putting to the social network as a style, either latent style or more specifically what are the hashtags for fashion related posts been, or what have the influencers been posting, or even more what has been being searched in the Google search query. What are people searching for when they want to buy something? These are all stuff that we should take into account when doing the prediction beyond just images that are very, very structured on the runway.
Well, we've talked a bit about different areas of how machine learning solutions can help with fashion. Maybe to wrap up, I'd love to get your take on things going the other way around. What are the challenges and questions that fashion pose that might push machine learning people to invent new methods and come up with clever ideas?
So I personally a strong believer that even though we are creating all these fashion recommendation system, recommender engine, it is not a good thing to push people to buy more just because we are understanding more about them and then just making people to have impulse buy more and more easily. It should be the other way around because fashion as a whole industry has been creating a lot of environmental issue, the waste and the over mass production and people overbuying. That has been a huge pollution source for the whole world. I believe with machine learning, what we are able to solve includes several folds actually. The first is for recommendation. We will be able to help consumers to better understand what they like and they further cherish things they like so that they don't have to overbuy anymore because whatever they are being recommended to and they actually make the purchase, they will actually like it and they will keep it for a longer time. And the second is that is a more long-term research goal, which has been happening right now already. That is, I think, a manufacture on demand or made by demand. So based on what we know about a person, right now, the person can also input their preferred fit and also what they envision, what they want to wear to be. And then only by that, we will then produce that piece of apparel to them. So back in the days, that would be a completely tailor-made and that should have been very, very expensive. But now with all these new machine learning trends, being able to automatically create patterns and so on, that should save the cost by a lot. So I think these two things will be where the next direction should go to.
Well, those are very interesting things I haven't even really pondered before. I guess clothing could become very custom and on demand in that regard. Do you have any thoughts on how that will make the colors and garments we're wearing in the future look? Is this going to have an overall, impact of more diverse styles, or will we all kind of streamline?
I really hope it will be more diverse, but looking at how the information are being exchanged right now, I think it is moving towards the direction where everyone is looking more and more similar. So one of the things that I was reading about the Wide and Deep network the other day is that when we look at the wide side of the Wide and Deep network, it is trying to memorize what has been happening before. So you will always recommend things that is highly similar to what the users have previously purchased before, whereas the deep part can try to generalize, so create more diverse recommendation. And I think that is what the responsibility of recommendation part should also take into account. Not only recommending things that you are very safe about people will like, probably risking the fact that everyone will look the same, but also introduce some kind of diversity or some kind of exploration to the user and the consumers as well.
Yusan, where can people follow you online?
I'm mostly on Instagram and I'm also on Twitter, not as active as it should be. So if Instagram is yusan.lin, And if it's Twitter, it's Yusan_Lin.
We'll have links to both in the show notes. Thanks so much for taking the time to come on the show and share your work.
Thank you for having me again, Kyle. Thank you so much.
That concludes another installment of Data Skeptic Time Series. Our guest today, Yusan Lin. Thanks to our sponsors, Data IQ and VPLS. Myself, Claudia Armbruster, as associate producer, Vanessa Bly, guest coordinator, and our host, Kyle Polich.